Optical isomerism is shown by those compounds which possess chirality, that is, which do not possess any elements of symmetry. Presence of an element of symmetry makes molecule symmetric and renders it optically inactive. That means if a molecule is symmetric, it is optically inactive. When a molecule does not possess any elements of symmetry, its mirror image is not superimposable on the molecule itself. This makes the molecule optically active. Such an asymmetric molecule can exhibit the phenomenon of optical isomerism. The two forms of the molecule, which are the images of each other, are called enantiomers. One form rotates the plane of polarized light in the clockwise direction, while the other in anti-clockwise direction. The former is called, that is, which rotates in the clockwise direction, is known as D form, and the other one which rotates in the anti-clockwise form is known as L form. The phenomenon of optical isomerism is quite common in coordination compounds. The complexes whose molecules are asymmetric exhibit optical isomerism. The optical isomerism of various types of complexes are discussed below. 1. 4 coordination compounds. In that, 2 sections, square planar complexes and tetrahedral complexes. In square planar complexes, all the 4 ligands and the central metal atom lie in the same plane. Therefore, they possess a plane of symmetry and are generally not chiral in nature. This is why optical isomerism is not common in square planar complexes and is very rarely observed. That means give reason why optical isomerism is not common in square planar complexes. Give reason. 2. Tetrahedral complexes, organic compounds having asymmetric tetrahedral carbon atoms are generally optically active. Therefore, it is expected that tetrahedral complexes with 4 different ligands attached to a central metal atom or ion, the complex of the type capital M, that is the central metal ion, A, B, C, D, the small letter A, B, C, D represents the 4 ligands, should exhibit optical activity. However, by practically they are not showing any optical activity. The reason is that it is not possible to resolve optically active D and L forms of such complexes due to labile nature. That means separation is impossible at its nature. Thus, optical isomerism is not very common in both square planar as well as the tetrahedral complexes. Only a very few 4 coordination complexes are known which exhibits optical isomerism. That is very rare. In short, theoretically, both square planar and the tetrahedral are not capable to show optical isomerism.